Welcome back to my lecture on probability and statistics, and in this section we're going to talk about percentiles, quantiles, and quartiles. So the best way to start is to redraw a standard normal distribution centered around 0 with a variance of 1. And the first thing we're going to do is we're going to mark the median, and we're going to note that the median right here is defined such that 50% of our data lays to the left of it. So when we wrote our median, it was something along the lines of the probability that our random variable z is less than or equal to 0 equals 0.5 or 50%. This means that 0 is equal to our 50th percentile, which is our median. And we did that with I believe, a tilde. So since the median divides our distribution into two equal parts, our median is a quantile. What if we want it divided into 4 equal parts? That would be quartiles, which are a special case of a quantile. So we're going to keep our median, and right here, we're going to say that we have some unknown value. I don't know what it is, but we're going to call it the 25th percentile, or our first quartile. That means that 25% of our data lies to the left of this point. And then over here, we're going to do the same thing, and we're going to describe our 75th percentile, or our third quartile. And you might be thinking, where's the second one? Well, the second one's the median. This brings us to what's known as the 5-number summary. And this gives us a good way to visualize a sample. A sample will have a minimum value, it'll have a maximum value, it'll have a 25th percentile, or a first quartile, it'll have a 50th percentile, or a median, also known as a second quartile, and it will have a 75th percentile, also known as a third quartile. Here we have 5 numbers. Now, another way we can draw this same standard normal distribution is we can use a box and whisker plot. So we can draw a line here representing 0. So this is 0, and this is Q2, our 50th percentile, also our median. And we're going to draw out our box all the way to our third quartile. And then on the left, we're going to do the same thing for the first quartile. This section of our box right here, between Q1 and Q3, this section right here is called the interquartile range, or the IQR. And then we're going to draw our whiskers out. So we're going to go from Q1, we're going to go out 1.5, so a little bit more than this. This is 1.5 interquartile ranges to the left, and then we're going to draw dots for every data point out to our minimum value, right? So this is our fence post, this is our minimum value. And then we're going to do the same thing, 1.5 interquartile ranges to the right from the left, and we're going to go out to our maximum value. Now, if a value exists past 1.5 interquartile ranges, if it goes past the fence point, then this is called an outlier. Not all samples have outliers, so this may or may not happen. You will always have a minimum, you will always have an interquartile range, you will always have Q1, median, Q3, and a maximum value. But some of your data, all of your data, may be within 1.5 interquartile ranges. One thing you might note is that your interquartile range acts as a measure of dispersion. This is true. Typically, you will use your interquartile range instead of your variance when dealing with a median.